be going over the pre-lab questions for lab activity 2.2. This pre-lab assignment is due at 4:30 on Thursday, October 24th. So we'll be doing the lab 2.2 after that, the week after that. So there are only 3 questions, and so I'm going to do some describing of the activity that we're going to do, because it's a little bit different than what's in your book. So number 1, describe the lab technique of gas collection via water displacement. How will you use this technique in the activity? Well, if you remember the very first wet lab that we did, we used Alka-Seltzer and water and a big, large graduated cylinder with water in it, and we had tubing, and we displaced the water with carbon dioxide gas and collected that and measured it. Well, this is a similar principle but a different technique. So I'm going to show you the technique, and as I said, it varies somewhat from what's in the procedure. It's a little bit simpler than what's in your procedure. So I'm going to show it to you, and then you're going to write the answer to number 1. You're going to describe the lab technique of glass collection that we're using in this activity. So let's go to the procedure on page 63, and instead of using the pipette, we're going to be using a syringe. So let's look at that. Just to move some things around. And so it shows a pipette, and it has you use a ruler and make markings so that you can measure the volume in the pipette. Well, instead of using a pipette and going through that, we're going to use a glass syringe that already has the markings on it, so we'll know how much gas we collected. So we're going to use the rubber stopper and put it in the glass test tube, just as this is described here. So let's show you that. Let's move this now. And so we have the beaker, we have the test tube, and we have the syringe inside the test tube. So it's supposed to be airtight, so you want to make sure it's in there well, and that the syringe barrel does move. So there are 2 different gas collections. We're going to collect hydrogen gas and oxygen gas, and then we're going to react it. So for the hydrogen gas, you're going to use the zinc filings. Here they are. And you're going to use 1 molar hydrochloric acid, which is not concentrated, but it's enough that it can do damage if you spill it. So be very careful using this chemical. And so the zinc will go in the test tube, and the hydrochloric acid will go be filled up most of the way. But I'm going to demonstrate the collection of oxygen. So this is manganese, which is going to be in this little container here, manganese. And then we're going to be using hydrogen peroxide that we got from the drugstore, 3%. So I've already put the manganese filings in there, I should say. And so little pieces of manganese metal. And it says to fill it about 1/4 of the way, so I just estimated 1/4. And so then it says to fill up with hydrogen peroxide until you're about 2 centimeters from the top, which is a little less than 1 inch. So I'm going to use that marking right there on this particular test tube as an estimate. So put the hydrogen peroxide in there. Whoops, a little bit too much, but that's okay. And you can see what's happening right away is the formation of bubbles. So we have oxygen gas being formed, and the syringe barrel will eventually move up, as you see, and so we're collecting oxygen as that moves up. So this is water displacement. The water is being displaced. The gas is moving up to the top because it's less dense, and we've even getting some liquid in there, which we don't want. So I'm going to push it back when I'm done collecting. So I'm collecting some gas, and I will measure how much that is. So I've got some oxygen gas going on right now. So that's how we're going to collect the oxygen gas. So that's water displacement, so you'll describe that technique in question 1. Syringe with markings. Let's see, we can see right now I have, well, maybe if I put some white underneath it, a little bit easier to measure. I have about 1.5 milliliters of oxygen in there. Okay? So you're going to collect different amounts of oxygen, different amounts of hydrogen, and cause them to react together and see which is the best ratio. So that's the goal of this lab. We're going to make some water eventually. Okay, so then let's focus that in better. There we go. So now you'll describe that in lab technique in number 1. Okay, then number 2, consider reactions 7 and 8. So let's look at reactions 7 and 8, which are, I'm going to go ahead and write them down for you. These are on page 65, I think, or 66, something like that. Reaction 7, right there on, is zinc solid, which I showed you before, the zinc filings, plus hydrochloric acid, so we're showing it in the balanced form, and that's aqueous, it's 1 molar, yields zinc chloride, aqueous, plus H2 gas. And reaction 8 on the same page is our hydrogen peroxide, which is this hydrogen peroxide, H2O2, and that's aqueous, it's 3%, so that tells us it's in water. And oh, it just by itself. We do have the manganese in there, and we're going to talk about the manganese in a little bit. So it's present, but it's not part of the reaction. So actually the manganese helps the hydrogen peroxide come apart, so it forms the water in the liquid state plus oxygen gas. So both reactions have gas formations. So what do you expect to observe about this reactions that will indicate the reactions are actually occurring? Well, you saw the reaction occurring in our bubble formation, which are still forming, so I guess that would be the actual answer, that the gas is being formed. That's what we're looking for. That's what our product, our desired products are. And how will you know that they're actually occurring? Well, you can describe that. Okay, then using your textbook as a reference, explain how the manganese in the oxygen generator is the procedure is behaving as a catalyst. So as I said, the manganese is in the reaction, but it's not part of the reaction. So you'll need to look up the definition of a catalyst. Now this particular catalyst is providing us with the filings, so we have lots of surface area. So you're going to need to look up the definition of a catalyst and then describe how the manganese is acting as a catalyst within that reaction. So simple, short pre-lab to this week. That's it.